Welcome back, mathematicians. Today we are going to add and subtract in algebra, and this is found on page 77 in your textbook. Right, one can only add and subtract like terms. They're not like terms, you cannot add and subtract. So let's first understand what like terms are. Like terms are variables and exponents that are exactly the same. For example, if I'm looking for the x cubed terms, they all have to have x cubed. X squared and x cubed are not like terms. You'll better understand this if we go through the worked examples. So the letters or the variables will determine if they are like terms. So let's have a look here. I always start with the first one in my list, and I'm looking for anything that has an x and a y. Well, this one only has an x squared. Here I have an xy. So this 3xy and 4xy are like terms. There are no other like terms in that expression. Let's look at the next one. I always start with the first term in my expression. Right, remember what we said is that in algebra, we always identify the terms. Now we're going to go one step further and we're going to identify the like terms. So I have a look and I see here I have a 2a. I run my eye along the expression until I find the next a term. Remember, the sign belongs to the term that follows it. So 2a and 3a are like terms, but you can see that I have a b term there. So 3b and negative 3b are also like terms. So in that expression, we had two like terms that were a terms and two like terms that were b terms. Right, now we're going to see how much you understand. So the first thing we're going to do, copy the list. So now we've copied the list and we have to circle the like terms in each expression or each list. There's an a term, there's an a term. So your a and your 8a are like terms. Let's look at the next expression. Not an expression, list, sorry. So here I'm looking for a to the 4. Do you see I only look at my variables? A to the 4b 3, no. A to the 4b cubed, yes, these two are like terms because a is to the power of 4 and b is to the power of 3 in both of those. These are not like terms because here we have b to the power of 4 and this one would be b to the power of 1. The problem we have in this expression, in this list, is that these are not in alphabetical order. So the first thing we're going to do, we are going to write those in alphabetical order. So this should actually read 3ab squared. A squared b, a squared b. Now we're going to identify our like terms. Here is an ab squared. Here is an ab squared. So 4ab squared and 3ab squared are like terms. Now I look at the other two terms. A squared b, a squared b. So these are also like terms. But they are different like terms and therefore we circle in a different color. Let's look at the last expression. How many terms do we have? Well, I've got a term there and I have a term there. So this has two terms, which is also known as a binomial, but we always have to have our terms in simplest form. So if we have a look at this, m's are common, n's are common. So if I had to simplify that expression, it would be minus 2mn plus 7. So there are no like terms in that expression. Simplify the following expressions where possible. Now we're going to put together what we've learned. First thing I do, I should circle my terms. Then I try, right? So let's circle. This term is an x term, that term is a y term. So I actually have no like terms. So when we have that, you rewrite it as 3x plus 3y. I know it sounds silly, but if you just leave it like that, it appears that you don't know that you cannot simplify that expression. Right, let's look at the following one. ABC, BAC. Remember, the first thing we do is we're going to write this as 2ABC, and it's positive 2ABC. Again, and that will be negative, so we rewrite this whole expression 3ABC plus 2ABC minus, I'm going to rewrite this as ABC minus 2ABC. Circle the terms. I have 3 terms. They are all ABC terms. So these are all like terms. So I circle my like terms in the same color. When I add in algebra, I identify my like terms. I then write down the variables, the surname, A, B, C. So now, and then I work with the numbers. So now I have 3 plus 2 is 5. 5 minus 2 is 3. So the first thing we do, circle our terms, write down the surname, and apply the laws of integers. So in actual fact, all we're doing right at the end is looking at the 3, the positive 2, and the negative 2. Let's look at the next one. First thing I do is identify my like terms. By now, I'm hoping that we don't have to first circle all the terms and then look for the like terms. So I have a 5x here. I go, no, here's another x term. I'm identifying all the x terms. So when I do that, I have no more. In addition and subtraction, I write down the term or the surname, and then I apply the laws of integers. Remember, x is the same as 1x. We have an invisible 1. So now I work on the numbers only. 5 minus 4 is 1. 1 plus 1 is 2. So now I have 2x. I go and see I've got an x squared term and another x squared term. So when I simplify, I write down the surname, x squared. I now apply the laws of integers. I've got plus 6 minus 4, which will give me plus 2x squared. It's important that you write this plus down. We don't need to write the positive here, but you need to write it to join those two terms to complete your algebraic expression. Let's look at the next example. So the first thing I do is I understand that I have 1, 2, 3, 4, 5, 6, 7 terms, but now I'm going to identify my like terms. So the first thing I do, x is first, so I'm looking for all the x's. Here's the next x, And here's the next x. And remember, negative x actually means negative 1x. There's an invisible 1. So I'm going to gather my x terms together. I write down my x, my surname, and now I'm going to apply the laws of integers. So 6 plus 4 is 10. 10 minus 1 is 9. So this will be 9x. I go and look at the next one in my expression. I have a 2y term. Here I have a negative 10y term, and that is the sum total of my y terms. So my answer is going to be y. Write down the surname, and now I know that I've got 2. If I was looking on the number line, I have 2, and I've got to subtract 10, so I would land up at negative 8. So this is negative 8. I now look for the following like terms. I have a z term. Here I have another z term, so I write down the surname, or I write down the variable z, and I suggest you use the cursive z because what often happens is you rush and sometimes a z looks like a 2, or you mistake it for a 2. So I write down my z, and now I say to myself, negative 4. So if I was at negative 4, and I've got to plus 2, so I must add 2 onto that, and I would land up at negative 2. So I have negative 2z. That is a trinomial. It now has 3 terms, so I've simplified this expression to 9x minus 8y minus 2z. I have no more like terms, so that is the final answer. Let's look at the next one. The first thing I do is I identify the terms. There's my first plus, here's my first minus, so this will be one term, and this will be the next term. Right, this is different because as you can see, it has been written in expanded form. So I look at each term, a times a, laws of exponents, I write down my variable, and I add exponents. 1 plus 1 is 2. Plus 3, so I'm going to remember to do signs, numbers, letters. So all of these are positive, so it's positive. I only have a 3. I write down my a. When I multiply powers with the same base, I add my exponents. 1 and 1 is 2. Again, signs, numbers, letters. This is negative. I only have a 4, so I write it down. A multiplied by a is a squared. I write down my base, and I'm going to add exponents. Now, I have an a squared term, I have an a squared term, and I have an a squared term. So all of these are a squareds. So I write down my surname, or I write down my variable, a squared. I apply the laws of integers. Remember, invisible 1 in front. So now I have 1 plus 3 is 4. 4 minus 4 is 0. Now what does that mean? Remember we said that that would mean over here we have a multiplication sign. So 0 times anything is 0. So my answer is 0. Let's look at the last one. Right, the first thing I do is I'm going to identify my like terms because these are all simplified terms. So I'm looking for an x squared y. I have 3x squared y. Here I have minus x squared y, and remember your invisible 1. Right, so I'm going to write down the surname, or I'm going to write down the variable, which is x squared y, and I have 3 minus 1 will give me 2 x squared y's. This is my x squared term, and this is different to x squared y because it has no y. Here's another x squared term, so I write down my surname, which is x squared, and I apply the laws of integers. Plus 4 minus 4. So if I have 4 and I subtract 4, I will land up at 0. So now I have plus 0x squared. And remember, 0x squared, if I have 0x squared, I actually have no x squared. So my answer is 2x squared y. And that is a monomial because it has one term and the coefficient is 2. That's all for this exercise. Please will you go and do exercise 6.3. Thank you.